Hi, chemistry students. This is your Unit 12 lesson on molarity and dilution. Please have your guided notes available, and please also think about pausing the video and trying the problems as we go, writing down things you don't understand so you can ask questions when we talk about this in class. All right, with that, let's get ready to go here. All right, so we've been talking about solutions in class where you have a solute dissolved in a solvent. Now, solutions can be very concentrated or they can be very dilute. And oftentimes in chemistry, it's important that we know exactly how much solute and exactly how much solvent we have and what the concentration of the solution is, or else we can ruin an experiment. So in chemistry, we often use a unit of concentration that's based on the mole. And so to express concentration of solutions in chemistry, we will use a concentration unit called molarity, and you can see mole right there in the word. It has an abbreviation of a capital M. All right, so how do you calculate molarity? So for solutions with a solid solute and a liquid solvent, molarity is calculated, and again, the abbreviation for molarity is a capital M, as moles of solute over liters of solution. So the total volume of the solution at the end, not necessarily the volume of the solvent, because the solute does take up space, but how many liters of solution do you have once you have mixed it? So again, you've got three variables: molarity, moles of solute, and liters of solution. So I am going to give you two, and you're going to have to solve for the third. So sometimes you're going to have to just tell me what the molarity is, but maybe there'll be some times when you'll give me a solution and I'll need to know how many moles of solute you have in there, and you'll have to solve for that variable. Okay, so how do you do that? I'm going to show you a little algebraic shortcut for this particular equation of molarity equals moles over liters that you may want to write down. It's called a molarity triangle. So this is the algebra shortcut to help you solve. It's called the molarity triangle. You should draw a triangle and divide it into these three sections. In the left-hand section, you'll write the word molarity and the capital M, which is the abbreviation. In the top section, you'll write moles of solute and the abbreviation MOL. And in the right-hand section, you'll write liters, if you're British, you'll spell it that way, of solution with a big L as the abbreviation for liters. Now, how do I use this to solve? Okay, let's look at the next slide. All right, so the way this works is you've got this, and I could give you any of these variables. So if I give you molarity, you sort of cover the thing, or I ask for molarity, you cover the thing that I'm asking for. This will tell you whether you multiply or divide. If you have top and bottom, that's going to be a division. If they're side to side, that's going to be a multiplication. So to calculate molarity, you're going to take moles and you're going to divide by liters. To calculate moles, though, you're going to take molarity and you're going to multiply by liters. And to calculate liters, you're going to take moles and divide by molarity. Again, you can always just do the algebra, but this is always going to be the way this sort of works out. Okay, so now what I'm going to do is I'm going to show you three problems, one for each one of these situations, and we're going to solve them. And these problems have very simple numbers, so you can do the actual math calculation in your head. You don't need a calculator in the examples. Now, in the problems you probably will, but just because they're different kinds of numbers. So as I'm doing these, you may want to pause the video, look at these relationship, and see if you can solve it before I show you the solution. Okay, so let's get started. Here's the first problem. What is the molarity, capital M, if a 4-liter solution contains 2.0 moles of copper 2 chloride? And remember, copper is a really pretty blue ion. Copper salts are really blue, so when you dissolve them, they give you this very pretty blue solution. So look at your molarity triangle, look at the formula for molarity, and see if you can solve it. And you could pause it here, but I'm going to go on and show you the solution now. So for this case, I'm solving for molarity. So as I can see from my molarity triangle, it's moles divided by liters. I come up here and I get moles, 2, and liters, 4. And then my solution is 0.50 molar solution. Now, big M means molarity. And instead of saying molarity, we say molar. So I would say I have a 0.5 molar solution of copper 2 chloride. If a colleague were to ask me, what's the blue solution you have there and what's its concentration? Now, what does that mean? That means for every 1 liter of solution, I have half a mole dissolved. And that makes sense. If I have 4 liters and there are 2 moles dissolved in the whole thing, each liter is going to have half a mole dissolved in it. Okay, let's try the next problem. Okay, this time I'm asking for moles. So you might look at your molarity triangle or look at the formulas you've jotted down and think about how you would solve for moles. How many moles are needed to make 3 liters of a 0.5 molar solution of sodium bromide? So your boss comes to you and says, please make me 3 liters of a 0.5 molar solution, lab tech person, and you have to figure out how to do that. Well, you're going to have to figure out how many moles you're going to have to get of sodium bromide in order to do that. Now again, pause the video, see if you can figure out how you get moles from liters and molarity, but I'm going to show you the solution now. Okay, so again, the basic formula is moles over liters, but we're solving for moles. Using the molarity triangle, and we cover this, we can see that moles of solute is going to be molarity times liters. So from the problem, we have 3 liters and 0.5 molar, and the multiplication says that we are going to have to get out 1.5 moles of that sodium bromide. And again, it makes sense. Think about the unit analysis here. It's liters times 0.5 moles per 1 liter. So that's going to be 1.5 moles. Now, to do it more, you have to change this into grams, and that's going to be a part of the problems you have to solve as well. Okay, let's try the last situation where we have to solve for liters. How many liters is a 5 molar solution containing 10 moles of potassium chloride? And I thought this was kind of funny. Haha, this is a 5, see those are moles, can you see that? It's a 5 molar solution, haha. So how would you do this? This time we're solving for liters. Look at the formula, look at what I've given you, molarity and moles. How would you solve? Okay, I'm going to show you the solution now. Pause if you want to try it first. All right, so liters is moles divided by molarity. So if we have 10 moles and we divide it by 5 in terms of the molarity, that means we have 2 liters of that solution. In other words, if 10 moles are dissolved in 2 liters, then 5 moles per liter. So that's what a 5 molar solution would be. Okay? All right. So let's look at one that's slightly more complicated. And I do, stress that I think it'd be good for you to pause the video and try it yourself before seeing the solution. But let's read it. How many grams of potassium nitrate should be used to prepare 4 liters of a 0.5 molar solution? So again, the idea here is we're trying to figure out how many grams. If we have to figure out grams, the first thing we have to do is figure out moles. So we're going to use the molarity triangle to solve for moles, and then since we've been doing this all year, we're going to use molar mass and figure out how many grams that would be so we could actually make this solution. Okay, so here's the solution. How many grams of potassium nitrate should be used to prepare 4 liters of a 0.5 molar solution? So we're going to use moles equals molarity times liters of solution. So here we go. Moles of potassium nitrate, 0.5 molar. That's what we have. 4 liters, that would be 2 moles of potassium nitrate. Okay, you got to weigh those out. You got to convert to grams. So you're going to figure out the molar mass of potassium nitrate, which I have figured out right here to be 101.11 grams. And then we're going to take 2 moles and multiply by 101.11 grams per mole. And we'll use 3 significant figures because this has 3. Okay. And so we would weigh out 202 grams of potassium nitrate in order to make this solution. Okay. So we will weigh it out. We will put it in like a graduated cylinder or what you're going to use in a lab soon, a volumetric flask. We'll add water until the solution has 4 liters in it, and then we would have the solution that you need for your experiment. Okay? So you're going to get a lot more practice on this, but we're going to talk about one other thing you can do with these molarity problems before we close this video. All right, so we're going to talk about diluting solutions. So you already have made the solutions, but maybe it's too concentrated, okay? Maybe you need to change the concentration. So molarity can be changed by dilution. And dilution just means I'm going to add water. And again, when you dilute something, you're going to make it less concentrated. So as the solution is diluted, the molarity decreases. It gets less concentrated. Okay, why is this important? All right, now I want you to, and why does this work? I want you to remember something about this and the calculations we're going to do. Remember our molarity triangle, right? And you notice that molarity times volume, or molarity times liters, equals moles of solute, okay, of the solid. Now, if I dilute a solution, that means I add water to it. Is that going to change the amount of solid? No, okay? So we can use that to figure out new concentrations when we dilute with water. Okay, now why is this important? Well, I've got something here, if you can see in the little circle. I've got some me drops, okay? These are like, if I don't want to just drink water, but I want to drink some lemonade flavored water, I get these me drops. And you'll notice I would not just open the me drops and chug it because it's very, very concentrated. But it's really easy for me to carry around and for me to store. So I can make lots and lots and lots and lots of bottles of water with lemonade flavor without having to carry around those bottles of water. So if I have my reusable water bottle, I can put this on the shelf and my reusable water bottle on the shelf, and anytime I want some lemonade, I can put a few drops in, and I've got the concentrated solution on the shelf. It doesn't take up much space. Now imagine if instead of having the concentrated solution, I think this makes 32 servings, okay? So imagine instead of just having this and my one water bottle that I can always sort of make, I had 32 bottles of, on my shelf waiting for me. That would take up a lot more space. It would also be a lot less flexible. Suppose I want it to be really sweet sometimes and other times I want just a little taste. Well, I can adjust what I do. So that's what scientists do. They take something called a stock solution and they put the concentrated form of the solution on their shelf. And they know when they need a solution, it's very flexible because all you're doing is adding water, which is free from the tap, right? And you have your glassware that your one graduated cylinder or your couple graduated cylinders, and it doesn't take up the space of lots and lots of bottles. So the concentrated stock solution is really good for making the kinds of solutions that you need. Okay, so the formula for dilution, remember the moles are going to be the same. So if I put a couple of drops of me solution in to my water bottle and I decide it's, too sweet, I can always add more water, but that's not adding more of the solute, all right? So the moles initial, so what I put in the more concentrated form is going to be the same amount that I have in the diluted form. So we say molarity times volume initially of our concentrated solution will equal the molarity times the volume of the final diluted solution. All right. And again, we use V instead of liters because because this is a relationship sort of thing, and as long as the volume is the same unit, you don't have to worry about changing it to liters. Now, if I asked you to calculate the actual number of moles, you would have to have it in liters. But since these are relative to each other the same, you could do both in milliliters. You could do both in cups as long as it's the same unit, okay? So let's try a few examples. A scientist needs 500 milliliters of 1 molar hydrochloric acid. The stock solution on the shelf is 12 molar hydrochloric acid, so much more concentrated. How much of this stock solution will he need to dilute 500 milliliters in order to get the solution he needs, to dilute to 500 milliliters in order to get the solution he needs? So again, you want to write out your variables. What does he need? This is the diluted solution. 500 is the V2. 1 is the molarity of the, or M2. And the stock solution molarity, the initial molarity, is 12. And we're trying to find out how much of this we need to pour out in order to get the solution we need. So let's go through this. M1V1 equals M2V2. So M1 is 12. That's the concentrated side. The diluted side is 1 molar. That's what we need. And we need 500 milliliters of it. So we're going to plug and chug. So there we've got it in there. We're going to divide. We're going to do 1 times 500 divided by 12. Remember, we are seeing like 3 significant figures here, 2 here, 1, 2 here. So the volume when we solve for V is 42 milliliters. So what does that mean? It means that you're going to pour out 42 milliliters of hydrochloric acid into your 500 milliliter graduated cylinder, and you're going to make the volume go up to 500 milliliters. Okay? So you're going to need to take out 42 milliliters of 12-molar hydrochloric acid and dilute it to a volume of 500 milliliters. So you'll be adding some water to that 42 milliliters until you get a volume of 500 milliliters. And again, this is just all about identifying the variables. Let's do one more, and then we'll be done. All right, Joe, chemistry student, has 100 milliliters of 6-molar hydrochloric acid. Let's assume that's 3 significant figures. What will the new concentration be if he dilutes it to 1 liter? Now, the only trick in this problem is we have 2 different units. So you can either change milliliters to liters, or you can change liters to milliliters, and that's what I'm going to do. This is his stock solution. He's poured out 6 molar at 100 milliliters because the stock solution is always the smaller volume. And I'm going to dilute it, basically I'm going to add 900 milliliters to it, to 1 liter. So that's our final volume. So again, M1V1 equals M2V2. This is his stock solution. He's got 100 milliliters of 6 molar. His new volume is going to be 1,000 milliliters. And then we're going to solve, and again, that's because 1 liter equals 1,000 milliliters, and then he's going to solve for M2. There we go there. And so your new, if you take your 100 milliliters of 6 molar hydrochloric acid and dilute it to 1 liter, add water until it's 1 liter, your new concentration is going to be 0.60 molar. Okay, you're going to have a lot of chance to practice now, and please be sure you ask questions, you do your practice in a timely manner, and I think you'll be able to get it. All right, thanks very much.